Hello everybody and welcome to the first lecture on the series Introduction to Computer Programming using Python Part 1. This is Class 01 Introduction to Programming. My name is Innocent Okoluku. Like we said in the synopsis, the course is based on the textbook of Eric Mathis, Python Crash Course, a hands-on project-based introduction to programming. The objectives of the class today is to discuss the concepts of programming and software, introduction to programming, to Python programming, setting up a computer and mobile device to enable the use of Python, or setting up Python in a mobile device and a computer. Also to write and run some basic Python programs. Why are we doing this? Because a good knowledge of the most common terminologies in computer programming and software is essential to understanding how to develop software. It's the same thing in every career. An in-depth knowledge of basic ideas and principles of programming is also an essential tool for analysis and design of software. We need to know the basic ideas and the principles so that we can design it in an informed way as a trained person in the profession. Understanding how to install and configure a programming integrated development environment as a basic tool for programming is essential. So if you want to learn a trade, one of the things you should know about the trade is how to set up shop, how to set up the equipment, tools you need to do the job. Learning outcomes. At the end of this class, participants should be able to explain some of the concepts and basic terminologies of programming and software development. Install and set up a Python programming environment on a computer and on a mobile device. Should be able to write and run some basic Python programs. Content. Introduction to programming, computer in many forms, still in the introduction, some popular software, some definitions, then proper introduction to Python programming, Python statistics, who is using Python, setting up the Python programming environment on a mobile device, setting up the Python programming environment on a PC, setting up an integrated development environment where we will use Visual Studio Code. Introduction to computer programming. First of all, we'll look at computers in many forms. Computers come in many forms. If I show this picture and ask you, is this a computer? Unanimously the answer would be yes, because this is the kind of computer that most people are familiar with. Of course it is a computer. Now, this is also a computer. It is called a Raspberry Pi computer. It's the size of a credit card, but it is a full computer, although with limited capability. This kind of small sized computers are usually called embedded computers because they are usually placed inside another device. For example, if I ask the Sony camera that just popped up, is it a computer or does it have a computer? Of course it does have a computer. Before the Sony camera popped up, another computer popped up. The Arduino computer, this one, which has something called a processor. This is the processor for the Raspberry Pi. This here is the processor for the Arduino. These are actually computers. The Arduino is a computer. The Raspberry Pi is a computer, but they are small form, small capacity computers So they are referred to as microcontrollers. Now, the Raspberry Pi, you can actually connect a monitor to it the way you do your desktop. Connect the keyboard to it, connect a microphone to it. The way I'm speaking in this video now, I connected the microphone to my computer. You can do it with this Raspberry Pi computer. It's a full-fledged computer that has its own operating system, but it is still an embedded computer that you can put into a camera, a refrigerator, a microwave oven, or something else, both of them. So when I look at this picture, I'm seeing several computers already. In fact, everything in that picture either is a computer or has a computer. Right. So what just popped up? FPGA means Field Programmable Gate Array. What does that mean? It is actually the processor or microprocessor which forms the computer. So this laptop does have a microprocessor inside it, which is actually the computer. If you use a Windows PC, you may see a sticker on top of the computer or somewhere around the computer that says Intel Core i7 or AMD Ryzen or something like that. It's telling you the type of processor that is inside the computer. From the programmer's point of view, as you will learn as time goes on, when a programmer says computer, the programmer is actually referring to the processor, not the whole package of the keyboard and the screen and everything. No, a programmer doesn't really see the keyboard and the screen and everything as computer. The programmer sees the processor as the actual computer. Okay, so we are seeing 1, 2, 3, 4, 5 computers already on the screen. So what about your mobile phone? Is it a computer? Of course it is. There is a processor inside the mobile phone also. And to say fact, these modern mobile phones that we are using today, they are more powerful than the computers that we used probably 2 decades ago, 1 or 2 decades ago. Actually much more powerful. So every person who is going around with a smartphone in his pocket is actually going around with a full computer. It already has the peripherals there. The touchpad is your keypad. The screen is your display. That is your monitor. Everything is right there. As you can see in this course, we are going to install Python on a mobile device, and we can be able to write our program directly from there and see the output, which tells us that the smartphone is a computer. So here is a flat screen TV that you normally keep in your home to watch programs and videos. Is there a computer inside it? Of course, yes. There could be more than one processors in this device. So, as a student of computer programming, you have a very broad range of areas where you can do your programming work. If you get a job in Sony, for instance, you are likely going to be writing programs for a lot of things. Sony is a big company. You could be in a position where you are writing programs to make cameras work, to control the shutter, the capture of the image processing, so on and so forth. Same thing goes if you got a job in a TV manufacturing company or wherever you got a job. So the programming experience is very broad, and it can take you to a very wide area of job. All of the things we saw in the last slide, none of them were moved. What we're seeing on the screen right now is the Sony Aibo robotic dog, which is actually a computer with actuators connected to it. You see, the laptop I'm using to make this video now has just one processor Intel Core i7, but this Aibo robot contains processors of the same capacity. That's to tell you how much computation is required to make the robot to work. A lot of programming work is involved. and making it to behave the way it behaves. This is Festo Flying Robot, which is actually a computer with sensors and actuators connected to it to enable it to fly like a real bird. This is the Boston Dynamics Spot robotic dog. Just take a time to see their behavior. Quite intelligent behavior. I don't think there's less than 2 computers in any one of these robots. And a lot of programming goes in there to make it work. Many of us are familiar with drones. They are becoming ubiquitous around us. Now, if you see this quadrotor drone, there is nothing less than 5 processors are actually controlling this drone to make it stable, to make it fly, to make it navigate the way you want it to navigate when you use your radio to control it. And it does involve a lot of programming. Each of the motors, the 4 motors, has a microcontroller, a dedicated microcontroller that controls its rotation, its speed, its stopping, so on and so forth. And then there are gyroscopes and there are compasses that enables you to know which direction it's facing, so on and so forth. All of them controlled by another central computer. That makes it at least 5 computers in the quadrotor. Although they are small scale computers like the Arduino, the one in the Arduino Atmel. This exciting video is a group of Boston Dynamic robots dancing. Quite exciting, isn't it? What you see there is a couple of humanoid robots and the spot robot and the stretch robot, all of them dancing. The humanoid robots are very, very complicated. All those limbs are connected to computers. They are also connected to gyros and a lot of other sensors and actuators that help the system to stabilize. And quite a lot of programming, very, very complicated programming goes into this kind of stuff. This is the Sony Vertical Takeoff and Landing Plane, VTOL. You can see the stability of the plane while it takes off vertically. Several computers and microcontrollers enable that behavior, and then it flies. It's able to navigate successfully and return back to where it came from by the use of computers. A futuristic phenomena that is already working, is already out there, is self-driving cars. This is Waymo, Google's self-driving taxi, being controlled by several computers, sensors, and actuators. It does involve a lot of programming. Okay, so these are many exciting forms in which a computer can be used, or where computers can appear and where programming job takes. So let's come to what most people think when they think about programming. Popular online shopping stores, Alibaba, Amazon, Konga, Jumia, Facebook, Instagram, LinkedIn, YouTube, WhatsApp, Pinterest, Twitter, so on and so forth. So all of these are computer programs that actually run on a computer. The fact that these programs do run in your mobile phone is a confirmation that your smartphone is actually a computer also. If you connect your Raspberry Pi computer, the small one I showed you before, the size of a credit card, if you connect it to peripherals like a screen and a keyboard, you can actually open a browser such as Chrome, and you should be able to shop from there also. So anybody that is starting any new career, the first thing they should do is to learn the lingo of the career, the language of the career, the terminologies of the career. So when they are reading things outside the class or interacting with other people who are professionals, they should know what they are talking. So we are going to learn some terminologies that we should be familiar to, future programmers. 1. Program. What is a program? It is a series of codes written in a computer programming language to perform a task, and tasks can be very many. Almost everything the computer does, from when you press the keyboard to when you click a mouse to when you say something, all of them are tasks. It is a program that actually responds to every activity you do. That's why you see something happens when you do something. The process of making programs is called programming. We have to write the codes, and the process is called coding. Either programming or coding is the same thing. So from a broader definition, we say programming is also the process of setting up something to perform an action, either in the now, in the present, or in the future. For example, you set up your alarm on your computer or your phone to wake you up by 4 a.m. or 5 a.m. because somebody has written the program to enable you to do that. The process is programming. What is software? It is a collection of programs that have been packaged with some other items such as images or files, which together serve a specific purpose. For example, if you have been using the word processor on Microsoft Word, or you have been using PowerPoint, every time Microsoft Word loads, you will see a beautiful interface on the screen. Every time Amazon loads, you see a beautiful interface on the screen. People have written programs, they've taken pictures, they've drawn some beautiful graphics, and then they put them together. And not only that, items such as files, information such as data that have been kept in some places called databases are also involved, could also be involved in the software. So they pop up, show some things, so on and so forth. We'll understand it better as we progress. So that's the general idea of software. There are different kinds of software which we see. One of them is called system software. What is a system software? It is the software that controls the operation of a computer. For example, when we started in the synopsis, I told you that for you to be able to follow this course, you need a computer that has a minimum of Windows 10 operating system or a Mac PC. Now, your mobile phone could also have an operating system called Android or iOS. This kind of software that enable the PC to function to begin with are called system software. So, when a computer was manufactured at the factory, a Dell computer, a Lenovo computer, an Apple computer was manufactured in the factory, the first thing they needed to do to make it to work, to even perform any action, was to install a system software, which is the operating system. So if there was no Windows operating system on the computer, it is almost useless. I couldn't have installed PowerPoint or Microsoft Word. We need the Windows first, or we need the Mac OS first in order to be able to install PowerPoint or Microsoft Word or Amazon or whatever else you want to install. So if you are using an Android phone, the Android operating system software must be on the phone first before you can download whatever app from the App Store. That's what system software does. Application software, on the other hand, is the software that is developed for some specific or related application, e.g. Microsoft Word, Microsoft Excel, whatever app you are using on your phone, whatever, those are application software. Embedded software is software that runs in a computer that is inside another machine. Remember, I showed you some embedded computers in the previous time. One of them is the Raspberry Pi, the other was the Arduino, and there are a whole lot of them. So an embedded software is The kind of software that will run in your microwave oven, washing machine, in a factory where we have a lot of machines that are controlling processes, manufacturing products, automatic welding machines, sprayers and all that. Such machines have computers inside them and they are programmed. Such kind of software that runs in those machines are called embedded software. Editor is a software that is used to type computer programs. Any software that you use to type is actually an editor, like Microsoft Word, Notepad, etc., etc. All of them are editors. You can actually use them to type a computer program. Integrated Development Environment is a software that is used to type, edit, debug, and execute computer programs. We know about typing, we know about editing. The concepts of debugging and execution are terms that we'll get used to as we progress in this course. So, the integrated development environment is like the laboratory of the computer programmer. If you are learning a new profession, one of the things you would learn is how to set up shop. That is, how to set up a lab where you will do the functions you perform in a job, the tools you need, the arrangement of a lab, so on and so forth. For us programmers, the IDE is our lab on the computer. Programming language is software that has some organized syntax and semantics to enable one develop computer programs. Every language has its syntax and semantics. For example, English language is different from Spanish, which is different from French, which is different from Portuguese, which is different from Mandarin. All of them have their different ways they are spoken and written, and you have to adhere to the syntax and semantics of the language you are learning. For us, that will be Python. Source code is the original program written in a programming language. Either you write the source code on a paper or you typed it on an editor and stored it. The program has not been executed in its raw form. It is called source code. Interpreter is a software that helps to translate source code line by line into executable code. The source code is the one you write. The executable code is the one that makes the computer to perform an action. Python is an interpreted language. Some other languages are interpreted languages also. So let me explain this further. The computer as it is, the processor, when it is created, is based on logic design, Boolean logic design, or binary arithmetic. So it's actually an electronic machine that understands two states, either a 0, which means a switch is off, or a 1, which means a switch is on. So the processor is made up of millions of these switches. The on-off position of the switches is actually the operation of the computer. That's the only language that your processor understands. But when we write programs in programming languages like Python, Java, C, C++, the language is closer to English language. We write the programs line by line, line 1, line 2. Some programs can be very simple, just a few lines. Some can be very long, complicated, a lot of lines. The computer itself, this processor, does not understand what we write in Python directly. So, what the interpreter does is that it is a program that has been created to stand as the intermediary between your Python program and the processor. So the interpreter is here. We will see this more clearly when we talk about compilers in the next definition. We continue with our definitions. Apart from an interpreter, there is also a software called a compiler. What this does is it converts an entire source code into an executable file. The difference between an interpreter and a compiler is this. For an interpreter, when you write your programs, it's like you are writing one line at a time, one line at a time, one line at a time. Programs can be very long. Some programs are 5 lines long, simple programs. Some are 10 lines. Some programs can go as much as 1,000 lines, 2,000 lines, 10,000 lines. An interpreter for something like Python is going to take one line and convert it to the language of the machine, take a second line, convert it to the language of the machine executes it, take a third line, so on and so forth, line by line. But a compiler for a language like Java, C or C++ is going to read all the lines that you have from the beginning of the program to the end of the program. It doesn't matter whether there are 1 million lines. It will convert all of them to the language of the processor once and keep it as a file. The advantage of compiler languages is that they will tend to run faster than an interpreted language that every time you run the program it has to look at it line by line. The compiler has already converted everything to one executable file in the language of the processor. So the advantage is that it runs faster. Assembler. An assembler is a software that is used to program a specific computer processor. It cannot be used for a different processor. So we saw different computers on the screen. We saw a laptop that contains an Intel Core i7. Intel Core i7 has its own assembly language. So if you write an assembly language program for Intel Core i7, you can run it only on every laptop or computer that has an Intel Core i7 processor. You may not run it for an Intel Core i5 or Core i3 or any other processor for that matter. If you write for a Core i3 processor, you can only run it on other Core i3 processors. If you write it for a Raspberry Pi processor, that is the Broadcom processor in the Raspberry Pi, you can only run it on a computer that has that same kind of processor. So assemblers are actually closer to the processor. So a program that is written by an assembler will run faster than the one that is written for a compiler. And the one for a compiler will run faster than the one that is written for an interpreter. So what I'm saying in effect is an assembler program will run faster than Java, C or C++, and a Java, C or C++ program will run faster than a Python program. An app is a software that is designed for a single purpose and a single function. I believe most of us are familiar with apps. We have a lot of them installed in our phones, our mobile phones, and on our systems. Utilities. Utilities are system software. Remember, we mentioned operating system as a software before. Okay, now operating systems don't just function alone. There are also a lot of supporting software that make an operating system to function. Such kind of software, you may not use them to do some actions like typing a document or preparing a spreadsheet or presentation, but they have specific functions. The moment you start your computer, they load up. So they help to maintain the proper and smooth functioning of a computer system. Okay, we'll see more of that as we progress. Now, related to utilities are software that we call drivers or device drivers. These device drivers help to connect computer hardware devices together. For example, if you just go to the shop and buy a printer and you just come home and try to plug it to your computer, it may not function unless there is a way for the printer to connect with your computer. You know why? The processor on your computer is different from the one on your printer. So, they cannot communicate directly unless there is a bridge between them. Such kind of interpreters are called device drivers. So, normally what do? You install the printer driver. The same thing with a lot of devices that you connect to the computer. You have to install the device driver for that device in order for it to be able to function properly. Device drivers are also system software similar to utilities. They work directly with the operating system. Matching language. So we have talked about interpreters, compilers, assemblers. Now we talk about matching language. This is the syntax of a specific processor. So, like I told you earlier on, a processor only understands two alphabets, 0 or 1. That 0 indicates a switch is off and 1 indicates a switch is on. You can actually write a program in the specific matching language of the processor. For example, you can write a program in the matching language of Intel Core i7 or AMD Ryzen. Now that is a hard thing to do. However, there are some programming operations in which the only way you can get something is probably to do the matching language programming. We won't be doing that. So, I mentioned assembler before, okay? So assembly language is the language that you use to write a program in the assembly language of a specific processor. The assembler, which I described before, is what stands between what you wrote in an assembly language and the processor for which that assembly language exists. So if I say an interpreter stands between your Python program and your processor, in that same way, an assembler stands between the assembly language of your processor and your processor. Good, we looked at matching language before we are looking at assembly language. So this will make me re-explain it in a clearer way. The matching language is the ultimate language, the language of the processor itself. Every program you write, whether Python, C, C++, Java, must eventually be converted to the matching language of the processor before the processor can execute it. Something always stands between the program you write and the matching language. For Python, it is an interpreter that stands between. For C, C++, Java, it is a compiler that stands between. For assembly, it is an assembler that stands between as the interpreter. Right. So, assembly language is faster than C, C++, or Java. C, C++, or Java, which is a compiled language, is faster than Python, which is an interpreted language. We also talk about low-level languages. What is a low-level language? Low-level languages are programming languages that are close to the processor. For example, matching language, assembly language, C, those are examples of low-level languages. C++, they are low-level languages. High-level languages are languages that are not close to the processor. And because high-level languages are not close to the processor, they can be used in a variety of computers. For example, if you write a Python program, you can run it on almost any computer. It doesn't matter whether it's Intel Core i3, Core i9, Ryzen, whatever, Apple, Mac, it runs everywhere. Same as Java, PHP, etc. That is the advantage of writing programs in high-level languages. Why is it that we have to have so many different languages? Some of them are closer to the machine, some of them are far from the machine, some of them can only be specific and all that. It all boils down to what you want to do, the speed at which you want it to execute. For example, I showed you a couple of robots that were dancing and performing gracefully. It took many years of research and development to get to that stage. If you want to write such kind of programs in which you require critical time response, you want very quick response, so that for that robot to balance in such a quick time, it's not falling. It needs the fastest response. The same thing applies to an aircraft. Consider a jumbo jet that is cruising at an altitude of 40,000 feet and a speed of 800 kilometers per hour. You want a very, very fast response. So when people build such kind of mission critical systems, a missile, an aircraft, a robot, something that requires very fast response, the focus is on using low-level languages in the programming process. C, assembly language, machine language, fast response. But if you want to design some other applications that has to do with a lot of data but doesn't require critical time response, like banking operations, database systems, records management systems and all that, preferably use a high-level language, Java, Python, so on and so forth. So, still on definitions, we talk about application programming interface. What does it mean? It is a collection of program functions that have been developed and added to a programming language or software to make programming easier for programmers. So, if you are writing a program for an embedded system, for instance, for you to be able to connect a keypad or a keyboard to such embedded computers, you have to develop the program itself that interprets your keypad just for you to be able to type something. But for a high-level language like Python that is on your PC, you don't need to do everything from scratch. You don't need to write a program to connect your monitor to the processor for you to be able to program, or to connect your keypad and all that stuff. So all these collections of programs, especially in high-level languages, that will make your programming work easier, as we will see as we progress, are called application programming interfaces. And we will use them a lot in Python. There is also something called built-in functions similar to application programming interface. In fact, a built-in function is a part of an API. So they are a collection of libraries in a programming language or software to make programming work easier. What do we mean by libraries? There are some things that are functions that people will use frequently. Some things are already defined. For example, pi is a number that is already defined in mathematics, including a lot of other things. There is no need for every person who wants to use pi in their program to start rewriting a function to compute pi all over again. So such kind of functions are built into libraries that people can use in their program to make things easy. So, what is Python? Python is a high-level programming language that is interpreted, like we saw earlier on. It was created by Guido van Rossum. Kudos to him, great man. He should be celebrated for providing opportunities to thousands of people, maybe millions of people across the world. You can read about him on this link in Wikipedia. So why are we learning Python? One of the reasons is Python has become the de facto teaching language for introduction to computer programming across the world. Another reason is it is simpler for beginners to learn Python. It is easier than C, C++, or Java. Moreover, Python has been a very successful language. It's not just a learning or training language. It is a very practical language, and it is well used across the world. Python is also a very versatile language. You can use it for a lot of applications. The applications range from desktop applications, kind of ones you will install on your computer, web applications, like we have seen some world-known websites that use Python, embedded applications. I showed you some embedded computers in the beginning of the course, the Raspberry Pi. Actually, the basic programming language for programming Raspberry Pi is Python. The moment you install the Raspberry Pi operating system, when you get a new Pi, Python is installed automatically for you. So you can use it for a lot of things. If you use it to build a robot, you can use it to control the motors, you can use it to build a drone, you can use it for home automation. So those are the embedded applications of Python. It's also used for artificial intelligence, computer vision, data science, and data analytics. It's very versatile. I picked up this image from the first book of Paul Barry, Head First Python. This is the first edition of 2011. I didn't find the picture in the 2017 version. So let's read what the lady is thinking about. Yeah, I need something that I can deploy on PCs, personal computers, Macs, handheld devices like iPad, Samsung Book, phones, across the web, on big servers, small clients. When we say big server, a server computer is a very big computer. Some servers, they can group them into clusters, and they could occupy a whole parking lot. For instance, why is it that Google can give millions of people free emails across the world? Google, Yahoo, Facebook, they have servers, data centers that are made up of servers located in different places across the world. You can deploy Python on those client computers. It says she needs it to let her build GUIs quickly and painlessly. What is a GUI? GUI stands for Graphical User Interface. That is any software that you can point and click something, like this PowerPoint I'm using, or a shopping web page, Microsoft Word, those are graphical user interfaces that you can see, point and click, and they are very beautiful. You can build them using Python. Okay, so somebody suggests for her that the language you need is Python. It's a good reason for us to learn it. So if we want to know information concerning programming, there are some authoritative websites in the world where they do research and analysis and all that. If you've never heard of the name Stack Overflow before, you should know about Stack Overflow if you are going to be a good programmer. You can go to the website stackoverflow.com and register as a member. You don't have to, but I strongly suggest you do that. If you are writing a program, you are trying to learn programming, and you run into some bottlenecks while writing a program for a particular task, go to Google and type it. Chances are someone else has encountered the same problem before, and someone else across the world has provided a solution. Most times the solution would have been provided in Stack Overflow. The question would have been narrated there, and several solutions would have been provided. Stack Overflow also does research on software programming, everything that is related to this. So they provide useful research feedback which can give you information about what is currently happening in the software market. So what I have here is a survey that is conducted in 2022 about which of the programming languages are the most used, the most popular in the world as of 2022. Our data says that JavaScript is the most used language in the world, followed by HTML and CSS, SQL, structured query language, and Python follows. See, Python is still very popular. The reason why JavaScript, HTML, and CSS and SQL are in front is that the world needs so many websites. A lot of processes need websites to show them, and one of the fastest ways to build websites is JavaScript, HTML, CSS, and when there is a website, they have to deal with a database, so structured query language is basic. So Python is a good competitor in the world stage at the moment. So what this tells us is, if you get a knowledge of Python, devote your time to study Python, you are opening a great door of opportunity for yourself in the near future. So, who is using Python? 16 famous companies that use Python in their operations are listed here. You can see them, some of them you know. These are big names, the top names, some of the top names in the world. Quora, edX, IBM, Spotify, Yelp, Pinterest, NASA, Reddit, Instagram, YouTube, Yahoo, Discourse, Eventbrite, Google, Dropbox, Uber. All of them use Python in one application or another. So it's worthwhile learning Python. That's the link to the page you are going. So the next thing we want to do is install Python on our mobile device, because that is easier to do than installing on a PC. I am using an Android phone, so it's quite easier for me to install on Android. Just go to Android Play Store and search for PyDroid 3 or PyDroid 4. As at the time of preparing this video, what we had was PyDroid 3. So you can click on it, select it, and install. If you are using an Apple device, you can go to the iOS App Store and search for any free Python 3 app. Select it and also install. In the class when I taught it the first time, a couple of students had an iPhone. It's the same easy installation. So they just installed it, configured it, and we were able to run the programs all together and have fun in that class, the first program I wrote. Okay, so after the installation, just click on open. Whether you are using an iPhone or an Android phone, is the same thing. Just click on open. So type the following program in the phone and click the run button. This is our first program in Python. I don't expect that you will understand what is going on in this program, but let's just have the fun. So what the program does is it sends a message on the screen, and the message says welcome, and in the next line it writes another message, guess the number. What the program does is it waits for the user to type a number on the keypad. You can type any number from 1 to 9, any number you want, type it there. And then if the number is equal to 5, the program will test it. Here the program is testing it, whether the number is equal to 5. If guess equal to. If you want to test whether something is equal to something in Python, you use the double equal to. That is, we are trying to say, see, this looks like English now, but not exactly like our English, but it does make some sense if you read it with your English language. If guess equal 5 is the same thing as saying, is guess equal to 5? If it is yes, print a message that says you win. But if it is not equal to 5, print another message that says you lose. Finally, print a message called game over. Program is finished. You can click this yellow button to run the program again as much time as you like and keep guessing the number. Normally, students should have fun doing this in the class, and then the class can continue from there. So, after doing that successfully, you can explore the PyDroid features or which of the apps you installed in your iPhone or your iPad, whatever. You can explore their features in other YouTube videos. So let's come to the main part. If you have your laptop or you have a PC right there with you, then we can go through the installation of Python on our system. At this stage, we are going to be pausing the PowerPoint slide and going straight to do the installation. So what I normally do is we'll go to the download side that is shown here, and then we download the program and do the installation. You follow me as I do it. So I will stop the PowerPoint presentation so I can copy something from here and go to a website. This is the reason why I told you earlier on that one of the things we need is a good internet connection so we can download as we progress. So let's go there. Click on a web browser and paste the site, and let's wait for the site to load. Now we are using Python 3.10.7. This was released September 6, 2022. If we download the later version, for instance there is Python 3.11, we could have done that, but as the new versions of Pythons are released, there are new features that are added, and some of the programs you wrote before may not run properly in the newer versions. So since the programs that are on this course were written for Python 3.10.7, I will suggest that you stick to that. This course will be updated as the year will go by, and then we can install a later version. But for now, please follow me to install 3.10. If you want the programs in these tutorials to actually run smoothly on your system. So we are going to install the Windows 64-bit installer. So how do you decide which of them to install on your computer? My own computer has a 64-bit Windows operating system. If you are using a 32-bit Windows operating system, you should download the 32-bit installer. So for us who are learning programming newly, how do we really know what operating system we are using? How many bits? If you can go to any Windows on your computer and go to the PC, this PC, right click on it and go to properties. That's if you are working in Windows 10. We want to know about our system. So it gives us information about the system we are using. The important thing is we want to know the system type is a 64-bit operating system, x64 based processor. And that is the reason why we want to download the Windows installer 64-bit. So follow the note. Windows installer 64-bit. If your operating system is 32-bit, install that. If you are using a Mac OS 64-bit universal installer for Mac OS. So I'm going to click this now. Now the download starts. I'm going to cancel it. The reason why is because I had already downloaded it. If you had not downloaded it before, then you don't need to cancel that. If we go to the downloads, you discover that I have Python 3.10.7. So after you download, this is what is going to show on your download drive or wherever you are downloading to. Okay, so I didn't want to waste my data duplicating the file. If we go to the next page, we can begin the slide from current page. Okay, so this is now PC installation. The Mac installation will be similar. Double click on the downloaded file to install, and make sure you check add Python to path. Then click install now. You see the PowerPoint is on the screen in presentation mode. How do I see my folder? If you are using a Windows computer, just press the Windows button. So you can now click on the folder here, downloads. That's where we are going to. So double click on the downloaded file. Double click or press enter. It says install now. Don't just rush to install. Remember to click add Python 3.10 to path before you click install now. If you miss to click add Python 3.10 to path, you have to do some extra work to enable Python to function properly. So remember this. Click yes and wait for the installation to progress. Okay, we are done. We close it. After installation is successful, the Python IDLE, which is the basic Python IDE, will be displayed in the start menu or on the desktop, and it shows like this. So we want to test the Python installation now. In the Windows command prompt, type Python. How do you go to the Windows command prompt? Since we are still in presentation, press the Windows button on your computer if you are using a PC. If you are on Windows 10, which is the operating system I suggested, then you will have a box here that says type here to search. Just type CMD. That's the Windows command prompt. Click on it. Okay, so let's look at the note. Type Python at the command prompt. Press Windows button again. Click on the command prompt and type Python. We want to know whether Python is on the system. Very correct. So it tells you straight away that Python 3.10.7 is the one that has been installed on this system. So we know Python installed correctly. So we want to know whether the basic Python IDE was also installed on the system. How do we know that? First of all, we can open the desktop by moving your mouse to the edge of the taskbar. The taskbar is this place. is this bar where you say type search, and every other thing that is located here down to the extreme right, click on it. So we see our computer desktop, and we find out that the Python IDLE which uses this logo was not displayed, so it doesn't show there at the moment. Let's go back to the taskbar. If we click on the Windows button again, we can look at the start menu and discover that even though the Python IDLE does not show on the desktop, it shows here on the start menu. If you want to put any shortcut on a desktop, you right click on that app, go to more, open file location, and you will see the logo here. Right click on it and click send to desktop. Okay, so it's now in the desktop already. If we press the escape button to exit PowerPoint presentation mode, you will see that the IDLE is here. Okay, so we are moving from the slide to so that we can do some things on the desktop. Open the IDLE shell and type print hello Python students. So let me just copy this. If we come here and double click in the IDLE and we paste what we copied, it says hello Python students. So we know that our Python installation is functioning perfectly. So we can move on to the next slide and continue with the presentation. In case you missed to check add Python to path during the installation when I was given that warning, if you missed it, all hope is not lost. It means that you actually have to manually set the Python required environment variables by yourself. So please don't uninstall Python just because you forgot to check add Python to path. That's no need to uninstall. So setting up the environment variables is very easy. I think we can even go through that so that somebody does not get stuck while we are supposed to be continuing with the lecture. Okay, so in case you missed that, take a look at what we have here. It's something that is supposed to show in the environment variables where Python is located. So that is the reason why when you type Python in CMD, it was able to recognize it. If you forgot to check add Python to path, then it was not recorded here. And if you come here and type Python, it's going to tell you not recognized. If you missed that in Windows, what do you do about it? Just open any folder at all, my documents, whatever. So documents folder, anything that will show this PC, right click on it and click on properties. So you will come to the right and say advanced system settings. That opens up environment variables. Click on it. Inside environment variables, look for path. Click on path, click on edit. So you will see that Python is not listed here. You have to list Python here manually. Okay, so there are two variables, user variables and system variables. If Python is not listed in any one of them, that is when Python will not show here and you cannot use it. It has to be listed in one of them, either the user variables or the system variables. In this case, it wasn't listed in the system variables. However, if it is listed in the user variables and I am the user that logged on to this Windows session, then I can run Python. Let's edit it and see whether Python is there. Of course, Python is there. But if you forgot to check add Python to path, then it is neither going to appear here nor is it going to appear there. So if it didn't appear here, you have to look for it and put it here. In fact, let's test something. I am going to delete it. I'm going to delete what we have from here. So we have two references to Python, 3.10 slash 3.10 scripts slash. Let's delete both. We delete this and we delete this and we say OK and say OK. Now let's go back to let's close environment variables. Let's go back here. You have to close this window and reopen command prompt, cmd again. If you have called cmd once, next time you click there it will show. You don't need to type. Let's type Python again. Python it's taking you to Microsoft Store. Why? Because it doesn't recognize Python anymore. It doesn't know where Python is installed, even though Python was installed. So how do you know where Python was installed on your system? Click on this search again and type app data. Start it with the percentage sign and close it with the percentage sign. It's going to take you to a window. App data roaming. Now you have to leave roaming and click on this app data. Then double click on local, go to programs, and you will see Python. The issue is, these days when you install a program, it's no longer being installed in program files like it used to be with Windows 7, Windows 8. It now comes to app data. So if you double click Python, you will see that Python 3.10 is listed here. We now know where it is. We are going to now go back to the environment variables and try to set it up. Right click on it, properties, advanced system settings, environment variables, and then for users you can set it, the path for users or the path for system. I could have set any one of them, but it is better to set it for system variables. So if I log out of this computer and someone else log into this computer, the person should also be able to use the Python, not just for me alone. So I'm going to click on this path under environment variables and I'm going to click on edit. So I say new. Now I will come back to my Python path here, click on this box until it is selected and press Ctrl C. Right click on it and say copy. Then come to environment variables, say new, paste, and put the slash. That is one. New again, paste it, put the slash, then type scripts and put the slash again. We are good to go. OK. 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 The next time we go to CMD, we type Python. Yeah, perfecto. Okay, so this is what happens if you had checked add Python to path. You wouldn't need to go through all this unnecessary stress, so try to follow the instructions as closely as possible. Continue the class from the next slide. We have successfully installed Python on our system and we can use it just like that, but it is not good enough. For more efficient programming in Python, you need to install another app that is called Visual Studio Code. So, like we did before, we are going to go to the website of Visual Studio Code and download it. You see, these things are free, and I am very grateful to the people who are producing these things and putting them online there for people to use to improve their life. Thanks to them. If we go to Visual Studio Code, for me to be able to copy, I have to leave the presentation mode. I press the escape button on the computer. So I've left the presentation mode, copy the link, open any web browser, paste it there, and press enter. If you are on Windows This is the one you are going to download on this side. If you are on Mac, this is the one you are going to download. If you're on Linux, which is another operating system, this is the one you are going to download. So we are on Windows, and I am using a 64-bit operating system. So what does the note say? The note says download the 64-bit one. So I press the Windows button on the keyboard. I can see my link again. So I'm going to click the first one here to download. When the download starts, I'm going to stop it. The reason is, if I download it, I will have two files. I already downloaded it before on the system, but if it finishes downloading, it would have been stored on your download folder in Windows or wherever else you wanted it to download to. So I have Visual Studio Code right here on the system. So we are going to double click on this to install. Accept the agreement. Next, next, next. Create a desktop icon so that we don't have to go through the process of doing it ourselves. Install. We now wait for the installation to complete. Very good. So we can launch Visual Studio Code. This is Visual Studio Code. What normally happens is, if you installed Visual Studio Code for the very first time, you've never installed it on your system before, what you are going to see here may be a little bit different from what you are seeing now. It's going to ask you to choose an interface. There is an interface that is all white. If you prefer a whiter background, there is a slightly dark interface like this one that is pretty ash colored, and there is a totally dark interface. It's up to you. I learned that a pretty dark interface is better for the eyes than a bright, very bright interface, so that's why I chose this. Okay, so I am not installing Visual Studio Code for the first time, so what you will get may be different from what I have here at the moment. Whatever happens, you should be able to get to this point where we have this. If you're having any problem with the installation, post a message in the chat section or send me a message on my email, and I will be able to respond to you as soon as I have time. Let's go back to the slides and continue from here. After we have installed Visual Studio Code, that is not all. We need to configure it for Python in order to be able to use it with Python. You see, Visual Studio Code is provided by Microsoft to make coding easier. You can use it to write programs as an editor for a lot of programming languages like JavaScript, Java, C, C++, Python. So whichever programming language you are using it for, you have to configure it so that you can be able to do some work there more efficiently. So we are going to install 4 packages in our Visual Studio Code in order to make it to work more efficiently for us. Press the Windows button on your keypad so you can see the taskbar. Click on Visual Studio Code. The first thing we want to install is Python IntelliSense Microsoft. So if we go back to Visual Studio Code and we will now click on this extensions. We want to extend the capabilities of Visual Studio Code. If you type, I didn't even need to type it before it showed here. Python IntelliSense is the first thing that shows. So you come here and click install. It is now installing. So you can see how many people have downloaded it. There is already 72.6 million downloads. Actually, it's not like 76.2 million people actually did the download. I think I personally must have downloaded up to 20 times. Installing, uninstalling, installing, uninstalling, so on and so forth. All of them are counted here. Okay, but at any rate, this number of downloads shows that it is widely used by a lot of people. So Python IntelliSense has been installed. The moment you see this uninstall here, we know it has been installed successfully. The next thing we need to install is Python code snippets. So if you come here and type Python code snippets, press enter. So we have code snippets for Python. Click on install. It has been installed. The next thing we want to install is AREPL for Python. Click on install. AREPL has been installed. Last thing we want to install is AutoDocString. AutoDoc. Okay, docstring. Installing. So everything we need has been, the 4 extensions we need have been installed so far. But before we go, there's something else we need to do. We need to set PyTest. So we go to settings, type test, and press enter. If we come back here, this takes us to settings, type test, and press enter. So we can scroll down to look for Python PyTest. We need to set it to enabled. We are looking for Python PyTest, then we need to check it to enabled. It's down below. Python testing, PyTest, or PyTest enabled. So it's already enabled. We need to check it to the good sign to show that it's enabled, and then we are done. We can now close all the settings windows. Just click this and drag it to the left and it closes the window. So this is what we have. Right, so we can progress with the class. After we have finished setting up our Visual Studio Code and Python, the next thing we want to do is try the Python installation, the Visual Studio Code installation, and the extensions we have installed to see if they are functioning properly. So we are going to test with this simple code we have here in this document. So normally, if you are learning programming, what you do is follow example codes, and you should do a lot of typing. Don't just copy code and paste. Don't just download codes and run them. You won't learn well that way. It's good to type with your hands, follow the codes, type with your hands, and get used to the idiosyncrasies that are associated with typing a program. So this code on the right side, I've minimized the PowerPoint slide so I can be able to see both windows at the same time while I'm typing. To create your first program in Visual Studio Code, if the screen is expanded, then you can click on File, New File, Python file. The fact that Python is showing there shows that it has already been configured for Visual Studio Code. You can run the code. So a file is open for you, but the name of the file is called untitled. Now you can just type the program here as it is now and save it later. But what I do is I prefer to actually save the file using a file name, a specific file name to save it, so that while I'm working I can keep saving it, because sometimes you live in a locale or in an area where the power supply is not consistent, and your computer can go off anytime and you lose all the work you get. Practice the habit of saving whatever you are doing every time you make a change. Try to save. Okay, so we click on File, Save As. Takes you to a folder. Could be any folder. So let me tell you how I organize my folders. If you are going to do programming, it's good for your folders to be properly organized. For example, in this location I have two top level folders. First is Introduction to Computer Programming 1. The other one is 2. If I double click on the first one, it consists of several other organized folders. Classes contains the topic we are teaching, we will be learning about. So you can see here I have 11 folders for each of the classes, up to 12 folders from 00. Now we are on Introduction to Programming. I double click on it. Within this Introduction to Programming, there is another folder that keeps all the codes related to that chapter. So for example, if I double click on code, you see we have files there. You can name this file any name. Just say, maybe I say hello, and press enter. You don't need to type anything else. If you click save or press enter, the name has become hello.py. All Python files will have the .py extension. When you save things on a computer, edited things like a Microsoft Word document, it is usually given a file extension name like docx. For the newer Microsoft Word files, Excel will be xlxs, PowerPoint will be ppts, so on and so forth. So for Python is .py. So let's go ahead and type it. Now we are going to see the effect of IntelliSense code snippet as I am typing. I want to say import. The moment I say IM, it has already suggested import for me. So I just press enter on the keyboard and it has made my work faster. If we had been using the original Python IDLE, which came with Python when we first installed it, we won't have this kind of fantastic capabilities that we have in Visual Studio Code. Okay, so I say import OS and press enter. OS dot. The moment I click dot, code snippets gives me some suggestions already. So when I say I want to type system and I say SY, system has already been given to me and I just press enter. The moment I click and open bracket, it gives me the close bracket, and the moment I click an inverted comma, it gives me the second one, and I can just say CLS. Now you are not expected to understand what this code is doing at the moment. It's just to demonstrate what we have installed. So I say print. I just type P and arrow and it gives me print. Welcome to Python programming. So it knows fname already. I just press enter. Okay, so we've written all the codes. Now that we've written all the code, we can now expand this screen and see exactly how it is. So this is a simple program that should actually make meaning to you if you remembered our first program, which is the guessing game program. The only difference is this import OS and os.system cls. So we can run this program. First of all, you have to save your program, like I said before. How do you know if your program has not been saved? While you are making changes to the program, if you see this white ball, this little white ball here on top here, you know it has not been saved. So you just press Ctrl S on the keyboard, just like you would do if you are typing a Microsoft Word document, or you say File, Save. Whichever way you do it, when the white ball has disappeared, you know it has saved successfully. Now, let's take a look at this screen as it is now. Later we understand the ID of Visual Studio Code better, but for now, three important parts are this part where you type is the main editing pad. You do your document typing and editing here. Now at the bottom here is called the terminal. When you run a program, it is in this terminal that you either enter your input. If inputs are required for the program, you enter the input here, and the outputs also come out in the terminal. So to run your program, you see this arrow button here, click it, run Python file. So it says, welcome to Python programming. My name is Innocent Okoloku, and then it gives you back the command prompt. So what really happened in Python is, remember when we did CMD previously, we say CMD and it gives us the command prompt. You can see the similarities. So we could have run our Python program in the Microsoft Windows command prompt. This is called DOS command prompt, Disk Operating System command prompt. But Visual Studio Code actually took this command prompt and put it inside here as a terminal. So you don't always have to open this command prompt to run your program or type in your input and see your output. So the output came out here. So we see our system is working very well. Now, you don't always have to see your output here. If the program you are writing does not require you to enter an input, we could have written a program that says enter your first name, enter your surname, just like the guessing game program that says type a number and then it guesses if the number is 5 or not. Now, for such kind of programs that requires input, you may not see them in AREPL. But for programs like this that don't require input, the output of the program, you can see them directly as you are editing the program here. Okay, so how did I get here? Let me close this window again. This icon you see here is AREPL, which we installed. Now good, there is an error, so that in case we are having errors over there, we know what to do. It says error in the AREPL extension. This tells us that the AREPL extension which we installed is probably not compatible with our version of Python which we installed. Remember, there is a more recent version of Python, but we installed the 3.10.71, and we just installed the latest version of AREPL. We can do something about that. So we are going to install a lesser version of AREPL that is compatible with this version of Python, and then we can see the output. So we go back to extensions, AREPL again. Click on this. Just left click on this and let's see what happens. So it says install another version. Anytime you see this install another version, it means that Visual Studio Code already knows that the version of AREPL installed on your Visual Studio Code is probably not compatible. So we'll click on it and you will see all the versions that are available there. The most recent version was the one that was installed, which is too new for our version of Python that was about 6 months ago. So let's try to step it down a little. Suppose we come to 2.03 and see it is installing. Okay, it says it's installing. Let's wait. Right. After installing, you have to reload. Reload required. Click on the reload required and let's see what happens. Whether we can use it. Okay. So close. It's still working. Let's wait for it to finish working. It's done now. Now we are going to close this window and try AREPL again. We still have an error in the extension. Go back there. Install another version. 2.02 one year ago. Reload again. So it has reloaded. Seems like it's still working. Let's wait a little. So we'll give this a try now. Good. Apparently we don't have an error with this. It doesn't tell us that the extension has a problem. Now if you have AREPL open, all you need to do is try to make a change to the code. So what I'm going to do is I will delete one of these brackets and put it back. So you just see the output directly here. Print output. Welcome to Python programming. My name is Innocent Okoloko. So you really don't need to run a program if you have AREPL installed. If the program does not require a user to type an input like the guessing game, then you really don't need to run the program using the run button to see the output in the terminal. Rather, you can just be seeing the output directly as you do your typing. AREPL tells you the output. If you have an error, AREPL points out the error immediately. So this is the powerful capability that we can get from the use of Visual Studio Code and the extensions that we have installed, which is very worthwhile. So we can continue back to the slide and continue the slide from the next page, from current page. Right, so we have set up our programming environment very well, and that is going to be our laboratory. In fact, for Python programming, the whole lab that you need has already been set up and configured properly so that we can begin work earnestly from the next classes. However, if you encounter an error such as code is already running, it means that you probably mistakenly installed another extension called CodeRunner. So what do you do about that? If you follow the instruction we've given here thoroughly, step by step exactly, then you don't need to get here at all. You wouldn't get here at all. Okay? But in case you got here inadvertently, open Visual Studio Code go to settings like we went to settings before. We've done that before when we are trying to check the PyTest. So in the search setting, type code runner instead of test. Type code runner. Scroll down, tick the mark in run in terminal, and restart Visual Studio Code and try running the program again. That should work. So we have come to the end of the class, the first class, Introduction to Programming. Textbooks. Like I said before, the main textbook we are using for the course is the book of Eric Mathis, Python Crash Course, and the rest of the data is there. That is the second book, and that is the third book, and other materials you can find. So we have come to the end of the first class, which is Introduction to Programming. Please like, share, and subscribe for more videos. Thank you, and see you in the next class, which is Basic Concepts of Software Development.